All right, good morning. We are doing the very first lesson in customized geometry. This is lesson 1-2, points, lines, and planes, and welcome. All right, so hopefully you have your notes open, MT1 notes, and following along with us. You've clicked this YouTube link and you're going to be going along with. I highly recommend going through this. I'm glad you're watching this video because it will definitely help as you go through. All right. So the standards we're going to be hitting are right here. You'll notice that some of the information that's in here as we talk about circle, perpendicular line, parallel line, those kind of things, even line segment, we're not hitting those today in this specific lesson, but we'll be hitting pieces of these contents. They're mathematical content standards. And then those practices, we'll be doing some problem solving, perseverance, doing some arguments, critiquing, and attending to precision. All right, here are our goals for today. We're going to identify points, lines, and planes, and identify intersections of lines and planes. That's our goal. Okay. In geometry, points, lines, and planes are considered undefined terms because they're usually readily understood. You already know what a point, line, and plane are. You've used them in algebra. You graphed on a coordinate plane. You found ordered pairs that are represented by points that are on lines. So in geometry, these terms, they have similar meanings. So we're not starting from scratch. You kind of know what those are already. So you don't have to be stressed about these. You kind of know what they mean. What we are going to do is talk about how we name them. Very specifically, the way we write their names is very important in geometry, okay? So this is what I really want you to write down in your notes, okay? So here in your notes, let's get your pen ready. A point is a location. It has neither shape nor size. It's named by a capital letter. So if I was writing something down, named by a capital letter, super important, okay? So for example, this point over here, this dot, it's been named with the letter A right above it. So we would call it point A. Or you could even just write the letter A. If we had another point right here, we might put a B above it and we would call it B. But always capital letters. That's why sometimes we stay away from like letters like C, because C kind of looks like a lowercase. Not always do we stay away from them, but you could see where that letter might be confusing. Okay. All right. A line is made up of points. You could see that along a line, you could have infinite number of points. It has no thickness or width. There is exactly one line through any 2 points. So, you could draw this A and B up here in this box. You could draw a line through it. See that? Here we go. See how we put those 2 arrows on there? Because a line is infinite. It goes off infinitely to the left, to the right, on and on and on. It is named by the 2 letters that represent, or by the letters representing 2 points on the line, or you can give, so you can, by the 2 points on the line, or by a lowercase script letter. Script is kind of like the fancy italic. That means italic letter, okay? So for this one over here, you have a P and a Q for your 2 letters on that line. So you could call it line PQ. Or you could call it line QP. See that? You get some options here. Line PQ, line QP. Or if you don't want to write the word line, now we get this little symbol above there. Looks like this, P, Q, and then you draw a line above it with the arrows on either side showing that it goes off infinitely. Or you could do Q, P. It does not matter which order you put those letters in. Now, if there was another letter on this line, if there was, say, an R in the middle of there, R right there, you pick two letters. So now it could be P, R. Okay? Or R, Q. But only two letters. Okay? Only two letters. Ever. Or you get the one italic script letter. You can go line M, because see, they named it there. Let's go ahead and I'll get a different highlight here. Line M, because we gave it that script letter there. See it? Couple options. If we're doing italics, you get one letter or 2 points in the line. There we go. Something like that or that. Okay. And now the rules are going to get a little funky and you're going to get mad at me at some point because there are going to be times when it's okay to take the arrow off the top. And I'll explain when that happens later. But for now, keep the arrows on the top, okay? All right, next. How do we name a plane? A plane, first of all, it's a flat surface made up of points that extends infinitely in all directions. So right now, your desk, if you put your hands down on your desk, my hands are down on my desk. You can hear me patting my desk there. A desk is part of a plane. It is not an infinite plane though, because your desk is finite. It ends, it stops. But if you could imagine that your desk went infinitely, it was so big that it never stopped, that would be a plane, okay? Or the walls of this classroom, if they were so big that they never stopped, or the floor or the ceiling never stopped, that would be a plane, okay? And it's made up of infinite amount of points. I could put an infinite amount of points on this little plane here. And you have to imagine that these edges are just kind of showing you where the plane is, but they don't actually exist because there are no edges to the plane, okay? All right. So if you have to have at least 3 points to make up, to define a plane, because if you have 2 points, you've got a line, right? If I draw 2 points, I can make a line through them. But once I get a 3rd point in, that can't be part of the line, right? So now I have to include it into that plane there. So 3 points makes a plane. Okay, so exactly 1 plane through any 3 points that are not in the same line. Now how we name them, we don't have a symbol for a plane. There's no symbol. We always use the word plane. Always, 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 always use the word plane. So you can write on there, always use the word plane. Then you have one of 2 options. You can use a capital script letter. Here, I'll show you. A capital script letter. Here it is. That we use to name the plane. Remember, it was lowercase script letter for lines. It's capital for plane. Okay? Or 3 points. Those are your 3 options. And, oh, I better keep highlighting 3 points that are not on the same line. They may not be on the same line. So if you can draw a line through the 3 points, they cannot be used to name the plane. So like BCD, if I draw a line through B and C, D is not on that same line, so I can use BCD. So BCD. But I could also call it CDB. I could also do DCB, DBC. See, there are 6 different ways to rearrange those letters. All of them are appropriate. All of them are acceptable. Okay? It does not matter which order. So you can use any single one of them. So with 3 letters, there are 6 different ways to name them. Okay. Last one, array. Array is a line with a single endpoint or a point of origin that extends infinitely in one direction. So it has a starting point. And we'll deal with this 2 arrays in a second, but let's look over here at our example. This is array. Here is its endpoint. Okay? Or what I call the starting point. This is where it ends. And then it goes infinitely on. Okay? When we name it from its endpoint. We say it ends at B, goes through A, and goes on infinitely. And our symbol is always that. We always start with the endpoint and go on. This is good. You may not do this. This is bad. Okay, so we're not going to do that. Okay? Okay. Now, this part that I talked about, 2 arrays of an endpoint with the same endpoint make an angle. Kind of threw that in there because that gets tested in one of the ALEKS topics. So I wanted to make sure you understood that. So I'm going to zoom in here a little bit. If we have, say, point D right here, I'm going to make that a little skinnier. Let's go over here and make this one skinnier. There we go. All right, point D, and it's going up through point F up here. And then point D also goes through point E right here. You have 2 rays here. You've got ray DE down here. You've got ray DF up here. But it's made an angle. There's this angle in here now. And eventually we're going to call that angle FED. No, sorry, FDE, my brain. FDE. And we'll learn more about naming that in the next chapter. But 2 rays make up an angle. So 2 rays with the same endpoint make an angle. That's what you need to know there. And I will, let's see, get you highlighted here. This part right here is this information. All right. Okay. If you need to pause me at all or go back, write any of that down, go for it. Okay. Now let's go a little bit further. Space is defined as a boundless 3-dimensional set of all points. Space can contain lines and planes. Probably not going to have the word space that you're going to be tested over. But collinear and coplanar, you definitely need to know those. Collinear points are points that lie on the same plane. Collinear points are points that lie on the same plane. I bet you need to fill that blank out. On the same plane. Okay, non-collinear points do not lie on the same plane. So if you were to break that down, co means together, together, and linear, together, line, together on the same line. Okay? Okay, and so if we were to look down here at this example, points A, B, and C are collinear. That makes sense. A, B, and C are on the same line. So looking at the same thing over here, coplanar points are points that lie in the same plane. Which makes sense because we're going to break this together. Coplanar, together, plane, together in the same plane. And if we look over here, we have P, Q, and R as points in the same plane. Remember, this one is italic. That's that script. So that is actually the name of the plane. This is plane S. So it's not a point. All right. Now, here is my example. I have gone together and I've constructed this plane. It's a sheet of paper that models up a plane that has 4 points on it. Now imagine that there's a line. That stick is a line ABC, that all have those points on it. A, B, C are collinear, and D is not collinear. They're all on the same plane. Discuss why plane ABC is not an acceptable name for this plane. I want to show you a video that may help explain why. So watch this. Oh, I have to take my screen mirroring off. Hold on. There we go. Let's take this back. Will it let me play? Go. Nope, it's not gonna let me. So we're just gonna get creative. We're gonna show you it right here. Here we go. There we go. There we go. So tell me why plane ABC is not a good name for this plane. Go ahead and pause and think about it for a second, because I'm going to give you the answer, but pause and think about it. Okay. The reason, hopefully the reason you came up with why ABC is not a good name for it, and if I go back to this, is because, let's see here, ABCD, if we locked this into like this angle right here, like plane ADC, exactly in this orientation is not the same as exactly in this orientation, right? It's just not the same. They are not the same plane. They're in different angles, right? But the silly thing is that line ABC is in the same position no matter what. So plane ABC would not be a good name because points ABC never change their location. So they are not defined. They don't define the plane. This plane changes all the time. And plane ABC doesn't lock it in. Now, if I say plane ADC, now we're locked in. ADC says it has to be right here. And now I can't move. I can't spin. I can't do anything. You have to have 3 points that are not in a line together. Okay. And then here's another thinker for you that you can pause the video and think about. Can 3 points be both non-collinear and non-coplanar? Can 3 points be both non-collinear and non-coplanar? Think it out. Talk to another person. This is definitely a level 3 kind of question. I would recommend you think it out and talk to somebody. Definitely recommend. All right. Pause. Think it. All right. Practice 1. Use the figure to name each of the following. As we go into these, whenever we see practice, I'm going to pause for a second, let you go ahead and do these, and then I'm going to show you the answer. Pause the video. Okay. There are 6 possible ways that you could name that line containing point Q. And there they are. Or 7, actually. Sorry. Okay. And there are 4 or 5 different ways you can name that plane. Oh, not 5. My brain. The correct way to name it would be plane QST. Okay. Practice 2. Name the geometric terms modeled by the objects in the picture. I would recommend also you just pause the video and go through and do the rest of the practice. And then come here for the answers. Okay. A notebook can model a plane. The edges can be lines. Those points at the corner are just points. The quarter is a point. Let's see. The pen can be a line. Collinear points there for P, R, and Q. Coplanar points, good. Okay. Now let's talk about intersections. Okay, intersection of 2 or more geometric figures is the set of points that they have in common. 2 lines intersect at a point, and lines can intersect planes, and planes can intersect each other. Okay, so this is not written down, but I would recommend you write this down somewhere. 2 lines intersect at a point. 2 lines intersect at a point. 2 planes intersect at a line. So, show that. So if we have 2 lines, we go like this. There we go. At a point. They intersect. Cool. Now, if we have a line and a plane, let's see how Mrs. Cruz's drawing skills are going to do here. Okay, here's a plane, and we're going to draw a line down through it, and it goes down through the plane. When we see the dashed, that means it's gone through it. That's what that means, that dashed there. it's pierced the plane right there and it's gone through it. It goes through it at also a point. A line and a plane intersect at a point as well. And then if we have two planes, okay, now this one always gets me tricky here for drawing. Let's see if I can do it. And then it's going to come through it. Let's see there. I think. So then this part in the back starts to, here we go. And this part there would be, okay, and they intersect at a line, and we're going to make that a different color. There's going to be a point here and a point here, and that's going to be a line where they intersect. Okay. Two planes intersect at a line. Now, the best way that I can explain this one, think about the two walls of your classroom. Look up right now and look at the corner of the classroom. Look at two walls where they intersect. They intersect in a line, okay? Not at a point. They intersect in a continuous line, okay? So that's where they intersect. Okay, so now an example. Draw and label a figure to represent the relationship. QR and ST intersect at U. And they're going to give you all of the information. Q and R, they give you the coordinates. S and T on the coordinate plane. This is really good for brushing up your algebra skills and remembering where those points are. Remembering that X's come first. It goes X and Y. Remembering that your X is over here, that your Y is up there. Yep. So just practicing all of those skills, right? So they graphed their lines, figured out where they intersect. So they plotted QR, they plotted ST, and then they said point V. This is point V is coplanar with these points, but not collinear with QR and ST. Draw a label, and then they go back. Draw and label a figure to represent the relationship. So if they drew in these lines, and then they said, draw in point V. They did not tell us where point V was. All they told us was that it was on the same plane, but not on the same lines. So they chose to put V up here. Did it have to be there? No. Point V could be anywhere they wanted. So I'm going to choose, I love pink. Pink is my favorite. V could have gone here. V could have gone here. V could have gone here. Anywhere they wanted, as long as it didn't touch a single one of those lines. Any of these points was fine, guys. Doesn't matter. There's no wrong answer, except for anything on this line or on this line. Those were out of bounds. Okay? So one such point is -2, 3. That was an acceptable point. So now you get to go on and do practice 3. So go ahead and pause and try practice 3, practice 4. I believe there's just 3 and 4. Do the rest of the practice and then come back and check your work. Right. You're supposed to draw it in. And let's see, point Q Any certain place is okay. Here, your drawing should look like this. Check your lines. Make sure that you're doing good with plotting out your JK and LM. And then Q could go anywhere as long as it's not on the line, on either of those two lines. And then interpret drawings. Let's see. Okay. How many planes appear in this figure? Now you're not only doing the plane at the bottom, but then you're doing all of the planes on the surface of this pyramid. So you've got this one on the outside, this one, and then the two on the back. So 1, 2. So 1, 2, 3, 4, 5, 6. There should be 6 planes. Name 4 points that are collinear. All right, collinear means on the same line. There's only one line that has 4 points on it, and it is this guy, HICF. Name the intersection of plane GAC. Plane GAC. And plane P. So here's plane GAC and plane P. Well, they intersect. 2 planes always intersect at a line, and they run into each other right here. So they have in common those 2 points, GC. So we're going to say GC or CG. Either one is fine. And at what point do JI and DC intersect? Explain. JI and DC. Now let's go over here and erase all of my other stuff. JI and DC. They're never going to intersect, guys. This JI and DC are in this plane, solidly in this plane, in plane P, and JI is piercing plane P. It only touches right here at I. It's only ever going to touch at I, and DC is never going to touch I, so never. They will never touch. So, yep. All right. And then let's go on to practice 5. Refer to the figure, name 3 points that are collinear. That would be AD and B, or DAB. BAD, any order.